There is a woman known in the scientific literature only as SM. She has a condition called Urbach-Weave disease, a rare genetic disorder that causes calcium deposits to form in soft tissue. In her case, the deposits destroyed her amygdala, both of them bilaterally, completely leaving the rest of her brain entirely intact. The amygdala is the brain's primary fear processing center, and SM cannot feel fear. Not reduced fear, not manageable fear, no fear at all. Researchers have exposed her to haunted houses, tarantulas, snakes, clips from horror films. They've shown her threatening faces, they've taken her to exotic pet stores, and encouraged her to handle whatever she wanted. Nothing, no fear response, no elevated heart rate, no instinctive recoil. She approached a snake with the relaxed curiosity of someone looking at a houseplant. She found the haunted house amusing rather than frightening. She's been robbed at knife point and held at gunpoint. She said she wasn't afraid during either incident. She was annoyed. And here's the thing about SM's life that the absence of fear has produced. It has not made her life better. It has made it significantly more dangerous. She has repeatedly put herself in situations that fear would have steered her away from. She has been victimized in ways that a functional fear response would have prevented. Fear is not the enemy. Fear is information. The fear response starts before you're conscious of it. The amygdala receives sensory input and evaluates it for threat before the information has reached the cortex, before you've consciously processed what you're seeing or hearing. The threat signal goes out before, there's a threat. Your heart rate rises, your pupils dilate, blood redirects from digestion to muscles, stress hormones flood the bloodstream, and then you become aware of what you're looking at. This is why you flinch before you've decided to flinch. Why you're already moving before your conscious mind is finished asking, what was that? The system is designed to act faster than thought, because in the evolutionary environments where it developed, the things that threatened you didn't give you time to think. Joseph Ledoux at New York University mapped what he called the low road and the high road of fear processing. The low road goes directly from sensory input to the amygdala, fast, crude, approximate. It generates the immediate threat response. The high road goes through the cortex, slower, more accurate, more nuanced. It evaluates whether the threat is real. The low road fires first every time, which is adaptive when the stakes are high enough. Better to flinch at a stick that looks like a snake than to stand there evaluating whether it actually is one. The cost of a false positive is embarrassment. The cost of a false negative is death. The problem is that the modern world is full of things that trigger the low road without presenting actual physical danger. Public speaking, social rejection, financial uncertainty. The amygdala doesn't distinguish between a predator and a performance review. The physiological response is the same. Chronic fear is one of the most damaging physiological states a human body can sustain. The stress hormones that prepare you to fight or flee, cortisol, adrenaline, are designed for short bursts. The threat appears, you respond, the threat resolves, the hormones clear, the system returns to baseline. When the threat is chronic, when the stressor is ongoing, when the nervous system stays activated, those same hormones that are helpful in short bursts become destructive over time. Chronic cortisol suppresses immune function, impairs memory consolidation in the hippocampus, disrupts sleep architecture, accelerates cardiovascular disease, and literally shrinks the prefrontal cortex through neurodegeneration. The body being afraid all the time is the body being slowly consumed by its own survival response. Post-traumatic stress disorder is in part a dysregulation of the fear system. The amygdala has been conditioned by an extreme threat to remain hypervigilant. Cues associated with the trauma, sounds, smells, locations, emotional states, trigger the full fear response even in the complete absence of danger. The fear system learned that a specific context was maximally dangerous, and it generalized that learning too broadly. It's doing exactly what it was designed to do, protecting the organism from a recurrence of something that almost killed it. The problem is the threat isn't there anymore, and the system can't easily be taught that. What therapies like EMDR and exposure therapy do is essentially reteach the amygdala, presenting the fear cues in a context of safety repeatedly until the association between the cue and the threat response weakens, until the low road learns that this particular signal no longer means danger. It works not for everyone and not completely, but it works often enough to be the gold standard treatment. Fear of death is the meta-fear, the one that underlies most of the others: fear of heights, fear of disease, fear of social rejection. Follow most fears far enough down and you arrive at extinction, the threatened end of the self. Terror management theory proposes that awareness of mortality is a constant low-level anxiety driver in human psychology. That much of what humans do, the monuments we build, the ideologies we adopt, the legacy we seek, is motivated in part by the need to manage the awareness that we will die. The cultures that handle death anxiety most gracefully tend to be ones that have integrated death into daily life rather than quarantined it, where death is familiar, named, present, not hidden away in hospitals and avoided in conversation. Proximity to death in that context reduces its power as a source of anxiety rather than increasing it. Right now, your nervous system is doing something that fear cannot do. It's resting. The amygdala is quieting, the threat detection systems are going offline, the low road is closing down for the night. Whatever your day contained, whatever triggered the low road, whatever had the cortisol running, it's behind you now. The body knows the difference between then and now. Right now is safe. The system knows, let it stand down. Arrest now. In 2019, humanity saw a black hole for the first time. Not an artist's impression, not a computer simulation, an actual image constructed from radio telescope data collected simultaneously by 8 observatories positioned around the planet. A telescope effectively the size of the Earth pointed at the center of a galaxy called M87, 55 million light years away. What came back was a ring of orange light around a dark circle, the photon ring light being bent into a ring by the extreme gravity of something so massive that nothing, including light, can escape from inside it. The black hole at the center of M87 has a mass of 6.5 billion times the mass of our sun. If you placed it where our sun is, it would swallow everything out past the orbit of Pluto and the event horizon. The point of no return would extend nearly that far again. It is the size of our entire solar system, and it is one of the smaller supermassive black holes we know of. The event horizon is not a physical surface. There's no wall, no membrane, no place where you would feel yourself crossing it. If you fell into a black hole, you would pass through the event horizon without any immediate sensation of having done so. What the event horizon represents is a causal boundary, a point past which the geometry of space-time has curved so severely that all paths, including the paths light takes, lead inward. You can no more escape from inside a black hole than you can travel into your own past. The geometry of the place forbids it. From outside the event horizon, an observer watching you fall in would see something strange as you approach the horizon. You would appear to slow down. The light coming from you would be increasingly redshifted, stretched to longer wavelengths by the gravitational field. You would appear to freeze at the horizon, getting dimmer and redder, asymptotically approaching but never quite crossing. From your perspective, you'd cross it without noticing. The freezing is an artifact of how light travels in curved space-time. You'd be gone before the outside observer saw you cross. Inside the event horizon, the physics gets strange in ways that our equations describe but our intuitions can't follow. The singularity at the center is where general relativity predicts density becomes infinite, and the equations break down. A point of infinite density and zero volume. Physicists generally believe this means general relativity is incomplete, that a theory of quantum gravity would replace the singularity with something finite and physical that we don't yet understand. What actually happens at the center of a black hole is one of the genuinely open questions in physics. We have no theory that reliably describes it. Spaghettification is the technical term for what tidal forces would do to a human body falling into a stellar mass black hole, one produced by the collapse of a single star with a mass of a few dozen times the sun. The gravitational gradient near the event horizon of such a black hole is so steep that the difference in gravitational pull between your feet and your head would be enough to stretch you into a long, thin strand of matter. The tidal forces would tear you apart before you reach the horizon. Supermassive black holes are different. The event horizon of the M87 black hole is so far from the singularity that the tidal forces at the horizon are relatively gentle. A human body, or what remained of one after the journey, could cross the event horizon of a sufficiently large black hole without being immediately torn apart. You would then have some amount of time inside the event horizon before reaching the singularity. How much time depends on the mass of the black hole. For the M87 black hole, it might be years. Years inside the event horizon, moving inevitably toward a singularity the physics can't describe. Hawking radiation is Stephen Hawking's most celebrated theoretical contribution. In 1974, he calculated that black holes aren't entirely black. They emit a faint thermal radiation caused by quantum effects near the event horizon. The mechanism involves quantum vacuum fluctuations, the constant creation and annihilation of particle-antiparticle pairs that occurs everywhere in empty space. Near the event horizon, one particle of a pair can fall in while the other escapes. The escaping particle carries energy away over an enormous timescale. The black hole loses mass this way and eventually evaporates completely. For stellar mass black holes, this process would take longer than the current age of the universe to produce a measurable effect. For the largest black holes, the timescale is unimaginably longer, but in principle, every black hole eventually evaporates. Nothing is permanent. Even the densest, most inescapable structures in the universe eventually dissolve. The information paradox is one of the deepest unsolved problems in theoretical physics. When things fall into a black hole, their information, the quantum states that describe them completely, appears to be lost when the black hole evaporates, but quantum mechanics says information cannot be destroyed. Something has to give. Either general relativity is wrong about what happens inside a black hole, or quantum mechanics is wrong about information conservation, or both are wrong. And the truth is something we haven't formulated yet. The best minds in physics have been arguing about this for 50 years. It's not resolved. There's a supermassive black hole at the center of our own galaxy, Sagittarius A star, about 4 million times the mass of the sun, 26,000 light years away. Scenario right now, tonight, it is sitting at the center of the Milky Way, doing what black holes do, warping the space-time around it, occasionally consuming matter that strays too close, completely indifferent to the fact that on one of the spiral arms of the galaxy, it anchors a small creature is lying in the dark thinking about it. The scale of indifference is total, and somehow that's not frightening. It's just the universe being what it is, a vast, old, mostly empty. And here you are in the warm part. Arrest now. The oldest tattooed human we have found is Otzi the Iceman. He was discovered in 1991 frozen in a glacier in the Alps on the border between Austria and Italy. He had been there for 5,300 years. His body was so well preserved that researchers could determine his last meal, his health conditions, the contents of his stomach, the fact that he was murdered, shot with an arrow from behind. And he had 61 tattoos? Not decorative tattoos, functional ones, simple marks, lines and crosses, concentrated on his lower back, knees, and ankles, precisely the joints that showed signs of arthritis and degenerative wear. The tattoos correspond almost exactly to acupuncture points used in traditional Chinese medicine to treat joint pain, which means either the therapeutic use of skin puncture was independently developed in the Alps 5,000 years ago, or the practice is even older and more widespread than we thought. Or it's coincidence the marks happen to fall on those points for some other reason. The researchers who have studied it most carefully think it's probably not coincidence. 5,000-year-old pain management marked in skin. Tattoo evidence goes back further than Otzi and other forms. Figurines with marked skin have been found dating to over 10,000 years ago. The tools, sharpened bones, and obsidian blades with traces of pigment appear in the archaeological record across cultures globally from the Neolithic onward. Every major ancient civilization practiced tattooing. Ancient Egypt, mummies with tattoos, mostly women, mostly on the abdomen and thighs, possibly associated with fertility. Ancient Greece and Rome tattooed slaves and criminals for identification. The Japanese Ainu people used tattoos as spiritual protection. Polynesian cultures developed some of the most elaborate tattoo traditions in human history. The word tattoo itself comes from the Polynesian word tatau. The universality is striking. Like ritual and music, tattooing appears independently across cultures that had no contact with each other, suggesting it's not a cultural invention but something humans are disposed to do. The biology of tattooing is more complex than most people realize. When a needle deposits ink into the dermis, the layer of skin below the surface epidermis, it triggers an immune response. Macrophages, the immune system's cleanup cells, rush to the site to consume the foreign particles. Most of the ink they engulf, but some macrophages die in place with the ink still inside them, and the ink ends up permanently suspended in the dermal tissue. Recent research has complicated this picture. A French team found that the ink isn't just sitting inertly in dead macrophages, it's in a constant state of being engulfed and re-released as macrophages die and new ones arrive. The tattoo is maintained by an ongoing immune response, a permanent low-level inflammation that keeps re-ingesting and redepositing the ink in place, which means your immune system is actively working to maintain your tattoo.
Every day.
Indefinitely. The psychological research on tattooing is interesting and has shifted significantly as tattoos have moved from subcultural to mainstream. Early research focused on tattooed populations in clinical or criminal justice settings and found correlations with risk-taking behavior and antisocial personality traits. More recent research on the general population finds something different. People who get tattoos tend to score higher on measures of openness to experience. One of the big 5 personality traits associated with creativity, curiosity, and tolerance for ambiguity, they're no more likely to engage in risky behavior than non-tattooed people when socioeconomic and cultural factors are controlled. The correlation between tattoos and criminality was largely a correlation between poverty, marginalization, and criminality populations where tattooing was more common rather than anything intrinsic to the practice or the people who chose it. Pain is an unavoidable part of the experience, and people's relationship to it is varied and interesting. The skin has different densities of nerve endings in different locations. Bony areas with thin skin. The ribs, the spine, the knee, the foot are more painful than areas with more subcutaneous fat. The ditch of the elbow, the back of the knee, the armpit, these are notoriously sensitive. Some people describe the pain as meditative, the sustained discomfort that requires presence and acceptance rather than resistance. The needle as a forcing function for being exactly here, exactly now, not able to escape into past or future because the present is too insistent. It's a not uncommon description, the deliberate endurance of pain as a way of arriving fully in the body. The ritual aspect of tattooing is worth taking seriously on its own terms. In cultures where tattooing carries traditional significance, Polynesian, Maori, Japanese Irizumi, the process is not just the production of an image, it's a rite of passage. The pain is part of it, the permanence is part of it, the fact that something is being done to you that cannot be undone, that after this moment you will be permanently different. That's the point. The Western practice has lost some of that framing, but not all of it. People who get meaningful tattoos often describe them in ritual terms, a mark of a transition survived, a tribute to someone lost, an anchor to something that matters when other things feel unstable. The permanence that might seem impulsive from the outside is often, from the inside, exactly what's wanted. Not a decision that can be reversed, a commitment to a moment or a meaning that refuses to let itself be forgot. You carry your history in your body, whether or not any of it is marked on the surface. Every significant thing that has happened to you has left some trace in neural pathways, in the way your nervous system responds to certain things, in the posture you hold, in the way you move. The body is a record, most of it invisible, all of it real. Arrest now. The record is safe. It will be there in the morning. In 2011, a psychologist named Betsy Sparrow at Columbia University ran a simple experiment. She gave participants a series of trivia statements to type into a computer. Half the participants were told the information would be saved. Half were told it would be deleted. The participants who were told the information would be saved remembered it significantly worse than those who were told it would be deleted. Their brains had offloaded the memory to the computer. Why bother encoding something internally when the external storage is reliable and accessible? The brain made a calculation. This doesn't need to be in here. It's out there, and deprioritized the encoding. Sparrow called this the Google effect. The brain treating search engines the way it treats other people's knowledge, not remembering the fact, remembering where to find it, which sounds alarming and maybe is, but it's also something humans have been doing since the invention of writing. The extended mind theory was proposed by philosophers Andy Clark and David Chalmers. In a famous 1998 paper, the core idea is that the mind doesn't stop at the skull. Cognitive processes extend into the environment when external tools become sufficiently integrated into how we think. Their original example was a man with Alzheimer's disease who used a notebook to compensate for his failing memory. The notebook wasn't just an aid, it was functionally part of his memory system. Remove the notebook and his ability to navigate his life degraded in ways identical to someone whose internal memory had failed. The question they asked was, if the notebook is functionally doing what his hippocampus would do for a healthy person, what is the principled reason to say the notebook is not part of his mind? And then they extended it. If you know a phone number because it's in your phone, are you in some sense remembering it? If you navigate using GPS, is your sense of direction outsourced? If you think through a problem by writing it down, is the paper part of the thinking? The internet has accelerated this process to an unprecedented degree. The sum of recorded human knowledge is accessible from a device in your pocket in seconds. Any fact, any date, any name, any formula, any procedure available faster than you could retrieve it from memory, even if you had it memorized. This changes what it makes sense to remember. Memorizing the capital cities of every country is less useful when you can retrieve any of them in 3 seconds. The cognitive resources spent on that memorization could be allocated elsewhere. But something is potentially lost. Cognitive offloading has costs that aren't immediately obvious. Memory isn't just storage. The act of remembering changes the memory and changes you. Every time you retrieve a memory, it gets slightly modified by your current state, your current knowledge, your current emotional context. The memory and the person co-evolve. Deep familiarity with a subject, the kind that comes from having it genuinely internalized over years, produces a different kind of thinking than having access to information about the subject. The expert who has spent years living with a domain thinks differently about it than someone who can look up everything about it quickly. The connections that form, the intuitions that develop, the unexpected associations, these emerge from internalized knowledge in ways they don't emerge from retrieved knowledge. When you read a physical map and build a mental model of how streets connect, you develop a spatial understanding of a place. When you follow GPS turn by turn, you arrive at your destination, but you haven't built the map. If the GPS fails, you're lost in a way that map reading wouldn't have left you. The attention economy is a separate but related problem. Human attention is finite, and the internet is designed by very smart people to capture as much of it as possible. The notifications, the infinite scroll, the algorithmic feeds that surface the most emotionally activating content. These aren't neutral features. They're extraction mechanisms competing for the same cognitive resources that memory and deep thinking require. The research on multitasking is consistent and depressing. Humans cannot actually multitask on cognitively demanding tasks. What we do is switch rapidly between tasks, and each switch has a cost, a resumption lag, a loss of context, a depletion of cognitive resources. People who report being good multitaskers are, on the research, measurably worse at it than people who don't multitask because they're less able to filter out irrelevant stimulation. Chronic high-frequency task switching appears to reduce the capacity for sustained attention over time. The brain that has been trained to expect constant novelty becomes less able to tolerate the sustained engagement that deep work requires. Nicholas Carr wrote a book called The Shallows in 2010, arguing that the internet was literally changing the structure of the brain, that the kind of reading and thinking the internet encouraged was developing different neural pathways than the deep linear reading that books encourage. The neuroscience he cited was real. The brain is plastic. What you do repeatedly shapes its structure, and there are measurable differences between brains that have spent years doing one kind of cognitive work versus another. Whether the changes are permanent, whether they represent genuine degradation or adaptation, whether the new cognitive profile is worse overall or just different, these questions are genuinely contested. There is something worth protecting in the capacity for sustained attention, for sitting with a single thing long enough to go somewhere with it, for holding a thought without looking it up or checking something else, for letting the mind make its own connections in its own time. That capacity doesn't require rejecting technology. It requires being deliberate about when you use it and when you don't. Right now, your phone is probably somewhere nearby, and you're not looking at it. The attention is here in the dark and the quiet, in the slow settling of the day. This is what the brain was built to do eventually. Not scroll, not search, not process notifications. Arrest, consolidate, make sense of things in the dark without any help. It knows how, let it. Stonehenge was built in stages over roughly 1,500 years. The first phase began around 5,000 years ago, 3000 BC. The last major construction phase ended around 1500 BC. The monument you see today is the accumulated result of multiple generations, multiple centuries, multiple communities, all adding to something begun before their grandparents were born and completed long after they died. Nobody alive during any phase of construction saw the finished monument. They were building something for a future they couldn't imagine, adding to something from a past they could only partially know. That fact alone does something to the conventional image of prehistoric people as short-sighted and primitive. These were people capable of multi-generational projects, of commitments that outlasted individual lifetimes, of a relationship to time that in some ways exceeds what most modern institutions manage. The engineering problem of Stonehenge is real and not entirely solved. The sarsen stones, the large upright stones and lintels that form the iconic trilithons, weigh up to 25 tons each. They were quarried at Marlborough Downs, 25 miles away. The blue stones, the smaller inner ring, weigh up to 4 tons each and came from the Preseli Hills in Wales, 250 miles away. Moving multi-ton stones 250 miles without wheels, without draft animals in the early phases, over terrain that included rivers and hills. Researchers have proposed sledges, rollers, rafts, human chains. Experiments have shown it's physically possible. The exact method used is unknown. The precision of the placement is what's more interesting than the transport. The monument is oriented to align with the sunrise at the summer solstice and the sunset at the winter solstice. With astronomical precision, the alignment isn't approximate. It's exact enough that archaeoastronomers are confident it was deliberate and that it required sophisticated understanding of solar movement across the year. 5,000 years ago, people were tracking the sun with sufficient precision to build a stone monument aligned to its extreme positions. That's not primitive. Stonehenge is famous, but it's not unique. The British Isles alone contain over 900 stone circles. Europe, more broadly, has thousands of megalithic structures. Dolmens, passage tombs, standing stones, alignments. The Carnac stones in Brittany consist of over 3,000 standing stones arranged in parallel rows stretching for miles. The passage tomb at Newgrange in Ireland predates Stonehenge by 500 years and is aligned so that the rising sun on the winter solstice illuminates a chamber deep inside the mound for 17 minutes. These are not isolated curiosities. They're evidence of a widespread and sophisticated tradition of monumental construction that stretched across Europe for thousands of years. What Stonehenge was for is genuinely uncertain. The astronomical alignments suggest it functioned as a calendar, a way of marking the solstices and possibly other astronomical events that were important for agricultural timing, ritual observance, or both. The winter solstice alignment is particularly significant, the shortest day of the year, the point after which the sun begins its return, the moment that in every pre-modern agricultural society represented the promise of spring and survival. There's evidence it was a place of healing. Human remains found at Stonehenge show a disproportionate number of individuals with significant health problems who had traveled from distant regions. Isotope analysis of their bones indicates some came from Wales, Scotland, the Mediterranean. The theory is that Stonehenge was a pilgrimage site for healing, a place people traveled to when they were sick, perhaps believing the stones had curative power. There's evidence it was a place of the dead. The surrounding landscape is dense with burial mounds. The monument itself contained cremated remains across its long history of use. It was probably multiple things to different people across the 1,500 years of its construction and use, projecting a single purpose onto something that served a community across that time span is probably a mistake. Mike Parker Pearson has led the most extensive recent archaeological investigation of the Stonehenge landscape. What he and his team found transformed the picture. A mile and a half from Stonehenge, they found Durrington Walls, a massive timber circle with evidence of enormous feasting and seasonal gathering. Thousands of animal bones, pottery evidence of large temporary settlements. This appears to have been where the living gathered. So Stonehenge, he argues, was where the dead were. The avenue connecting the two sites runs between a landscape of the living and a monument of the dead. The winter solstice procession would have moved from the place of feasting toward the monument of ancestors as the sun set, marking the boundary between the living world and whatever lay beyond it. A landscape organized around the relationship between the living and the dead, built over 15 centuries by people who kept adding to something their ancestors started. There's something I find quietly moving about Stonehenge that has nothing to do with the mystery. It's that it's still there. 5,000 years of weather, invasion, religious transformation, industrialization, 2 world wars, the Roman conquest, the Norman conquest, the Reformation, the Industrial Revolution. All of it passed over this landscape, and the stones are still standing. Not because anyone protected them through all of that for long stretches of history, nobody particularly did, but because they were too heavy to move and too embedded in the landscape to ignore, they outlasted everything. The thing you're lying in right now, whatever it is, whatever it's made of, will not last 5,000 years. But right now it's warm, and you're in it. That's the part that matters. The stones are cold and patient, and they can wait. You don't have to rest now. The morning is coming the way it always does. The sun will rise in the same direction it did when they built those stones. Some things stay the same. In 2015, Scott Kelly began a one-year mission aboard the International Space Station. He had a twin brother named Mark who stayed on Earth, identical twins, same DNA, same upbringing, same career trajectory, both NASA astronauts, the perfect control group. When Scott returned after 340 days in space, the researchers had something unprecedented, a before and after comparison of a human body subjected to prolonged spaceflight with a genetically identical baseline sitting on the ground. What they found was more dramatic than expected. Scott's telomeres, the protective caps on his chromosomes associated with aging, had actually lengthened during the mission, which sounds beneficial until you know that rapid telomere lengthening followed by rapid shortening is associated with cancer. His gut microbiome had changed significantly. His cognitive performance had declined measurably. 7% of his gene expression had changed. The same genes were present, but they were being turned on and off differently than before. 6 months after return, most changes had reverted. About 7% had not. Space had permanently changed his biology in ways his identical twin didn't experience. The psychological effects of long-duration spaceflight are in some ways more concerning than the physical ones. The ISS is the size of a large house. 6 people live in it for months at a time. They cannot leave. They cannot be alone in any meaningful sense. Every interaction is with the same small group of people. Every view out the window is the same view, the curve of the Earth, the darkness of space, the absence of everything familiar. The first few months tend to go, well, the novelty is sustaining, the mission feels urgent, people are performing. Around the 3rd or 4th month, something called the third quarter phenomenon sets in. Psychological research on isolated and confined environments. Antarctic stations, submarines, research stations consistently shows a dip in mood, motivation, and team cohesion in the period between the midpoint and the end of a mission. The initial novelty has worn off. The end is visible, but not yet close. The emotional and social resources of the group are depleted. Conflict increases. Astronauts on long missions describe a strange relationship to time. The days blur. The routine that helps structure the week also flattens it. Monday and Saturday become indistinguishable. The sense of time passing normally, anchored to seasons, to social events, to the rhythms of an ordinary life, is gone. The overview effect is the most discussed psychological phenomenon specific to space. Edgar Mitchell was the 6th person to walk on the moon on the return journey. He had what he described as an instant global consciousness, a sudden overwhelming sense of connectedness, of the interconnectedness of all life, of the pettiness of the divisions that occupy human attention from the ground. He wasn't alone. A remarkable number of astronauts have described something similar. The experience of seeing the Earth from outside, a small blue sphere in an enormous darkness, the borders invisible, the fragility obvious, produces something that cognitive scientists now study as a genuine psychological phenomenon. It's described as a sudden shift in perspective, so dramatic it feels like a perceptual change rather than just a thought. Not, I now understand the Earth is small, but I see it, the seeing precedes the understanding. Frank White named it in 1987 in a book called The Overview Effect. The research on it is still early but consistent. Something happens to many people when they see the Earth from outside. Something that changes the cognitive framework rather than just adding information to an existing one. The social dynamics in isolated, confined environments have been studied extensively because they matter for mission success. The dynamics in Antarctic research stations have served as a proxy for understanding what might happen on a Mars mission. Similar isolation, similar confinement, similar small group dynamics, minus the communication delay. What the research finds consistently is that leadership matters more than individual personality. Groups with clear, flexible, trusted leadership navigate the third quarter phenomenon and interpersonal friction much better than groups without it. The technical skills of the crew are less predictive of mission success than the social cohesion. Individual traits that predict performance in normal work environments, intelligence, technical competence, ambition, become less predictive in isolation. What predicts performance in isolation is emotional regulation, flexibility, the ability to tolerate ambiguity, and the ability to give and receive support. The skills that matter most when everything is stripped away are the human ones. NASA is planning for Mars. The journey one way takes between 6 and 9 months, depending on orbital mechanics. Once there, waiting for the orbital window to return takes approximately 18 months. The mission is measured in years. The communication delay to Mars at maximum distance is about 20 minutes each way. 40 minutes round trip. Real-time conversation with Earth is impossible. The crew is functionally on their own in a way that no previous mission has been. The psychological preparation for that mission is considered as critical as the physical preparation. How do you maintain mental health when you're further from every other human than any human has ever been? When the planet you came from is a point of light. When the delay means that by the time you ask for help, the crisis may be over. Nobody knows yet. It hasn't been done. The isolation that astronauts experience is extreme. The isolation most people experience is a much gentler version of the same basic human vulnerability, the need for connection, for context, for the anchoring that comes from being embedded in a world of other people. You're not in a space station. You're not 6 months from anything familiar. You're here on the planet, surrounded by the gravity that holds everything in place. The world is outside your window. People are sleeping in every direction. You are not far from anything. Rest in that the overview from here is fine. Music is the only thing that activates every region of the human brain simultaneously. Not most regions, every region, visual processing, auditory processing, motor systems, emotional centers, memory systems, language areas, the cerebellum, the prefrontal cortex, all of it lights up when you listen to music, and love. No other stimulus does this, not speech, not visual art, not movement alone. Which suggests that music isn't just a sensory experience processed in one place. It's something the entire brain participates in, something that the whole neural architecture, from the most ancient subcortical structures to the most recently evolved prefrontal regions, has something to do with why the human brain would be organized this way for something that has no obvious survival function is one of the more interesting questions in neuroscience. The chills are a good place to start. About 50 to 70% of people experience physiological chills, goosebumps, a shiver down the spine, a wave of something that feels like it moves through the chest in response to music. The experience has been studied, and it involves a genuine physiological cascade. Dopamine release activity in the nucleus accompanies the brain's reward center, elevated heart rate, increased skin conductance. The chills happen most reliably at moments of unexpected harmonic resolution, when a chord progression resolves in a way that was anticipated but arrives with more force than expected, or in a way that wasn't quite anticipated, and the surprise of rightness produces something overwhelming, or when a melody reaches a peak and holds it, or when a voice does something technically difficult with apparent ease. The brain is predicting. Music is a prediction machine for the brain. You anticipate where it's going based on pattern and experience. When the resolution is perfectly surprising, expected enough to feel inevitable, unexpected enough to feel new, something happens that goes beyond aesthetic appreciation into something physical. Music and memory are tangled in ways that are neurologically unusual. The part of the brain that stores musical memories appears to be different from the part that stores other autobiographical memories. People with severe Alzheimer's disease who cannot recognize family members, cannot recall where they live, cannot retain new information for more than seconds, can often still sing songs from their youth, can still respond to music that was meaningful decades before the disease. Henry was a man with severe amnesia, studied by the neurologist Oliver Sacks. He couldn't form new long-term memories. He lived in a permanent present with no access to his recent past, but music unlocked something. When he listened to music from his youth, he became more present, more himself, more emotionally accessible. The music seemed to reach a part of him that the amnesia hadn't touched. Sacks described it as music being a kind of identity, that the self is encoded in the music we love in ways it isn't encoded in facts or narrative. That when everything else has been taken by disease, the music is sometimes still there. The social function of music is probably its evolutionary origin. Robin Dunbar, the anthropologist who identified Dunbar's number, the cognitive limit on the number of stable social relationships a human can maintain, has argued that music evolved as a form of social bonding that could work at larger group sizes than grooming. primate social bonding happens through physical grooming. But grooming is one-to-one. You can only groom one animal at a time. As group size increased, grooming became insufficient to maintain the social bonds that held the group together. Language emerged partly as a solution. You can talk to multiple people simultaneously, share information, gossip, maintain relationships at a distance. Music is even more efficient when a group sings together or moves to the same rhythm. The bonding effect of synchronized movement and shared sound operates on everyone simultaneously. A campfire song bonds 20 people at once in a way that requires no individual interaction. Music also synchronizes physiology. When people listen to music together, their heart rates and breathing patterns move toward alignment. Their brain waves synchronize. They are literally being brought into the same physical state by the shared experience of sound. Minor keys and dissonance are culturally learned to a significant degree, but the emotional response to music appears to be partly universal. Researchers played Western music to the Mafa people of Cameroon, a group with no prior exposure to Western music or its conventions, and asked them to identify emotional content. They identified happy, sad, and fearful music at rates significantly above chance. The basic emotional vocabulary of music appears to cross cultural lines even when the specific conventions don't. And lullabies are remarkably consistent across cultures. Slow tempo, descending melodic lines, simple rhythmic structure, soft dynamics. Every culture that has been studied has lullabies that share these features. The features are not arbitrary. They correspond to what calms the human nervous system most effectively. The musical features of a lullaby are basically a list of things that reduce arousal, which is why it works. Your nervous system responds to music in ways that don't require conscious participation. The tempo of music entrains your heartbeat. Slow music slows you down. The brain follows the rhythm, whether you intend it to or not. This is why certain music is used in surgical settings, in therapy, in spaces designed for recovery. Right now, there may be no music, just the ambient sound of wherever you are. But the silence has its own rhythm. The breath, the heartbeat, the distant sounds of a world settling into night, your nervous system reading all of it, finding its own tempo in the quiet, slowing the body's own lullaby. You don't have to do anything with it. Just let it play. There is a fungus that hunts, not in a metaphorical sense, not in the slow, patient way that decomposers consume dead matter, actively hunts, sets traps, captures prey, digests it alive. Arthrobotrys oligospora is a nematode-trapping fungus. Nematodes are tiny roundworms, among the most abundant animals on Earth, present in virtually every soil sample ever taken, and Arthrobotrys has developed a mechanism to catch and eat them. It grows adhesive traps, small sticky knobs on its hyphae that nematodes blunder into and cannot pull free from. Once the nematode is caught, the fungus sends filaments into its body and digests it from the inside. Some species go further. They construct constricting rings, 3-cell loops that can inflate in 1/10 of a second. When a nematode passes through, clamping down on the worm with enough force to hold it, the nematode triggers its own capture by the act of moving through the ring. They'll set traps, wait, capture, digest. This is an organism with no nervous system, no muscles, no sensory organs as we'd recognize them, and it hunts. Ophiocordyceps is the genus that David Attenborough made famous. The zombie fungus, the most studied species, infects carpenter ants. The spores land on the ant's exoskeleton and germinate, penetrating into the body. The fungus then does something that shouldn't be possible. It manipulates the ant's behavior with precision. An infected ant will abandon the colony, which is unusual behavior for a highly social insect. It will climb a plant stem to a specific height. Researchers have documented this is almost always between 25 centimeters above the forest floor. And all of a sudden we have this little scenario. It will then clamp its mandibles into the underside of a leaf at a specific angle that maximizes humidity, the conditions optimal for the fungus to complete its life cycle, and it will die there. Then the fungus produces a stalk that erupts from the back of the ant's head and releases spores onto the forest floor below. The manipulation is so precise that researchers studying it initially couldn't believe a fungus was doing it. The ant does what the fungus needs done at the right height, on the right surface, at the right angle, with the fidelity of a program machine. How it does this is only partially understood. Early theories assumed the fungus was directly controlling the ant's nervous system, invading the brain and issuing commands. When researchers actually looked, they found something stranger. The fungus doesn't invade the brain at all. It surrounds the muscles. It wraps itself around the individual muscle fibers throughout the ant's body and appears to control behavior by controlling movement directly, bypassing the nervous system rather than hijacking it. The ant's brain may still be intact and functional, receiving normal signals from a nervous system that is connected to muscles that are no longer responding to it. The ant might be aware of what's happening and unable to stop it. That possibility has no confirmed answer. Ants don't tell us what they experience, but the mechanism as currently understood is arguably more disturbing than simple brain invasion. There are over 600 known species of Ophiocordyceps. Each is typically highly host-specific, evolved to infect one species or a narrow range of species, and to manipulate them in ways specific to their ecology. There is no known species of Ophiocordyceps that infects humans or any vertebrate. The biology is completely incompatible. This hasn't stopped it from becoming cultural nightmare fuel. The Last of Us dramatized the premise of a cordyceps-like fungus adapting to infect humans with considerable effect. The writers of that show consulted with fungal biologists. The scientists they spoke to confirmed that something like this is theoretically possible in principle. Fungal evolution has produced extraordinary host manipulation before they also confirmed it is not happening and is not considered a realistic near-term threat. The real Ophiocordyceps is confined to insects and its equivalents in other arthropod groups. Anemophora muscae infects houseflies. It compels the fly to climb to an elevated position before death. Then after death, it keeps the fly's wings extended, held up by fungal tissue growing under them, to maximize spore dispersal from the elevated position. The fly's body becomes a spore dispersion platform. The fungus uses the corpse the way an engineer would use a tool. Massospora cicadina infects periodical cicadas, the ones that emerge in enormous swarms every 13 or 17 years. The fungus replaces the cicada's abdomen with a mass of spores. The cicada continues to fly and behave normally, spreading spores as it moves, even as the back portion of its body has been completely replaced by fungal tissue. Some infected cicadas continue to attempt mating. The behavior spreads the spores to other cicadas through contact. The fungus has turned the cicada's reproductive drive against it. There is something philosophically strange about predatory fungi. The category of predator implies intention, pursuit, desire. These are organisms with no nervous system, no consciousness. By any definition we use, no wants. And yet they set traps. They manipulate behavior with extraordinary precision. They exploit biology with the sophistication of a designer who understands the system being exploited. It's evolution producing outcomes that look like intelligence without any intelligence being present, which maybe shouldn't be surprising. Evolution has had hundreds of millions of years and extraordinary selection pressure. Given enough time and pressure, optimization processes produce things that look designed. The trap that catches nematodes, the manipulation that positions the ant perfectly. These are solutions to problems refined over millions of generations until they work with near-perfect reliability. Just the blind logic of selection doing what selection does. The darkness outside is full of things that don't know you exist. Fungi threading through soil, nematodes navigating between particles, the whole invisible ecology of the ground doing its work in the dark. None of it is interested in you. All of it is necessary. The world running on processes too slow and too small to see, which is fine. You don't need to see it. You just need to rest in it. The ecology of the night is taking care of itself, as it always has. There is a psychological phenomenon called charismatic authority. Max Weber identified it over 100 years ago. He distinguished between three types of authority: traditional authority, which derives from custom and heredity; rational legal authority, which derives from rules and institutional position, and charismatic authority, which derives from the personal qualities of an individual that inspire devoted following. Charismatic authority is the most powerful and the most dangerous. It doesn't require institutions or traditions to sustain it. It flows directly from the perception that a particular person possesses extraordinary qualities, divine favor, exceptional insight, unique destiny, superhuman ability. The follower's loyalty is to the person, not to any rule or principle, which means the person's will becomes the only law that matters. Weber was describing a category. History has provided endless examples. The psychology of why people follow charismatic leaders, sometimes to catastrophic ends, is better understood than most people realize. It starts with uncertainty. People are most vulnerable to charismatic authority during periods of genuine uncertainty, personal crisis, social upheaval, economic disruption, cultural disorientation. When the normal frameworks for understanding the world are failing and the future is unclear, a person who appears to have certainty, who speaks with conviction, who seems to know what's happening and what to do about it, that person becomes extraordinarily attractive. The certainty they offer doesn't have to be accurate. It has to feel real. The confident framing of a confusing situation is a clear battle between good and evil, us and them, the enlightened and the blind. This provides cognitive relief. The anxiety of uncertainty is replaced by the comfort of a story where you know which side you're on. The charismatic leader's self-presentation has consistent features across wildly different contexts, absolute confidence, no visible self-doubt. The performance of certainty is critical. Hesitation and qualification undermine the authority that the whole edifice depends on. With special knowledge, the leader has access to truth that ordinary people don't. This might be divine revelation, secret information, unique analytical ability, or access to suppressed wisdom. The follower is privileged to be given this truth that others can't see. Personal attention that feels exceptional. Charismatic leaders are often described by followers as making them feel singularly seen and understood. The quality of attention, the eye contact, the apparent interest, the feeling of being truly recognized is experienced as overwhelming by people whose ordinary lives have provided little of it. Grandiosity paired with accessibility. The leader is extraordinary, chosen, exceptional, destined, but also genuinely interested in you specifically. This combination is deeply compelling. Jim Jones built the People's Temple through decades of genuine social work, feeding people, housing people, advocating for civil rights in ways that were real and meaningful. His early followers had good reasons to follow him. He was doing things that mattered. The catastrophe at Jonestown wasn't built on nothing.
Yeah.
It was built on something real that was corrupted incrementally over years. This is the pattern. The charismatic leader rarely begins in full catastrophic form. The qualities that attract followers are initially genuine. The corruption is gradual. The boundaries move slowly enough that each step seems like a continuation of what came before rather than a departure from it. People don't follow monsters willingly. They follow compelling people and watch them become monsters over time, by which point the psychological and social investment makes leaving almost impossible. Difference to authority is a deep human tendency rather than an aberration. Stanley Milgram's obedience experiments in the 1960s showed that ordinary people would administer what they believed to be severe electric shocks to strangers simply because an authority figure in a white coat told them to continue. The majority of participants, ordinary people not selected for any particular trait, continued to the maximum shock level when pressured by the authority figure. The experiment has been criticized on methodological grounds, and its replications have produced somewhat more variable results, but the core finding that authority substantially overrides individual moral judgment in a significant proportion of people has held up broadly. Milgram's conclusion was uncomfortable. He wrote that the capacity for obedience is not a personal failing. It's a feature. Human groups require coordination, and coordination requires deference. The same tendency that makes armies and institutions and cooperative societies possible is the tendency that makes atrocity possible under the wrong authority. The exit from a cult of personality, whether a literal cult or a political movement or a corporate culture organized around a founder's personal authority, follows a recognizable pattern. Something cracks the certainty, a specific event that doesn't fit the narrative, a behavior from the leader that's too obviously wrong to rationalize contact with someone outside the group who holds up a mirror, or simply the slow accumulation of dissonance that eventually reaches a threshold. The exit is painful because the certainty being abandoned was providing something real. Meaning, community, identity, a framework for understanding the world. Leaving means not just rejecting the leader, but dismantling the whole structure built around them and facing the uncertainty that the leader originally appeared to resolve. That's why people stay longer than observers think they should. It's not stupidity, it's the cost of exit being genuinely high. The protection against charismatic authority is not cynicism. Cynicism just makes you available to a different kind of authority. The authority of the person who confirms your sense that everything is corrupt. The protection is something harder. The capacity to tolerate uncertainty without needing it resolved by someone else's certainty. The ability to hold open questions open, to find the discomfort of not knowing preferable to the false comfort of premature resolution. Which is not a comfortable place to live, but it's an honest one. The questions you're holding tonight don't need answers. The uncertainty you carry doesn't need to be handed to anyone. It can just be what it is, yours. In the dark, which is fine. The dark is just the dark. Rest in it.